If I summed up the aim of the Spring framework, I would say something like, Spring makes Java server-side development simpler. You may also hear the term enterprise, but to me that simply means an application that needs to run on a server rather than a desktop. Just in case you've not done any Java enterprise development before, in particular with the Java EE libraries, let's have a quick overview of what that is. When developing software for an enterprise environment, you need to consider many more things, other than if you're developing on a standalone desktop application. Just having a development language like Java is not enough. We need to start thinking about things like how do remote clients communicate with our software, and how does our software communicate with other components on other clients. You also need to consider other concerns like transaction handling. When things go wrong, we want to make sure our data is kept into a consistent state, thereby ensuring data integrity. And also because remote clients can now communicate with our software, we need to start considering security issues, and we need to consider those quite seriously. Now in the Java world, these concerns have historically been services provided by third-party vendors. These services were bundled up into a neat little package known as an application server. The problem was, in the early 1990s, each vendor had their own set of APIs. So if you developed your application, for example, on an IBM application server, and you wanted to port it across to a WebLogic server, for example, you had real problems. Portability was a real issue, and even the vendors of the application servers saw this lack of coordinated API as a big problem. They saw it as a problem because getting widespread developer acceptance would be very difficult. So to address this concern, the Java EE standard was created. You may still see it referred to as Java 2 Enterprise Edition, but it's now been renamed to Java EE. The meaning of Java EE is just a specification, specifying the services that an application server must support in Java. The folks that created Java EE, they thought it'd be too hard for people to understand how to develop applications using the various services and their APIs. So they came up with EJB, or Enterprise Java Bean. It was supposed to be an easy way to access the application server's libraries. Back in the early days of 2000, everyone wanted to be into EJBs. It was a real skill set to have. But unfortunately, things didn't work out quite so well. After only about a year or so, people realised that EJBs were really quite complicated. They were complicated mainly because it was a poor design. They were very difficult to use and to write. Most of the development time in those days was spent debugging these things. Enterprise Java Beans, or EJBs, were a kind of all-or-nothing affair. You either had to use everything they offered or nothing at all. So you had the complexity of remoting, for example, even if you didn't want it. Say you just want to use the transaction handling part, you were kind of stuck with everything. Another problem was that they relied on 100% on running on an application server. Without an application server, these things were useless. It made it very, very difficult to run and test. However, EJB was the official standard, and many projects felt obliged to use them. In 2002, Rod Johnson wrote a book called Expert One-on-One, and it was brave because it challenged the status quo in the Java industry and asked the question, do we really need EJBs to make Java development simpler? The book tried to answer that question and went a long way to show how simple Java can be used using good design practices without the need for the complexity of EJBs. Luckily, Rod released his code to the open source community, and himself and a group of other enthusiasts developed it over time, and it became a full-blown framework. And of course, this is now called Spring. So now we can use the code that Rod and his team supplied to the same things as EJB, but using simple plain old Java objects. And more importantly, you choose what parts of the framework you need. If you're interested in using easier data access, you can do that without anything else. If you want to introduce transaction handling, you can do that without affecting your code. You may even realise you don't actually need an application server anyway. With Spring, You can often replicate what otherwise would need a massive application server suite to achieve. Like I said in the last tutorial, it's a bit like choosing from a menu in a restaurant. You only need to know about the bits you need. So in this tutorial, we talked about how Spring came about and why there was a need for it. It's not an official standard, it's a de facto standard. In other words, so many people have adopted it, it's kind of become an unofficial standard. Now in the next tutorial, I'm going to go through a brief history of the various versions of the Spring framework up to the present day.